So week 14 is all about representing data. The learning outcomes. There are 3 learning outcomes between today and tomorrow, and we're going to split all 3 between today and tomorrow. The first learning outcome is that you know how to produce charts and diagrams for tally charts, pictograms, bar charts, dual bar charts, pie charts, stem and leaf diagrams, line graphs, frequency polygons, histograms and scatter graphs. Hand in hand with that, so when we do each of these display types, we will do the second learning outcome, which is we will talk about interpreting them. Okay? In other words, what do they mean? How do I read them? What sort of questions do I get on them? Okay? And the final outcome is for tomorrow only, and that's specifically about scatter graphs. And something we have to do with these displays called scatter graphs, where we have to draw a line of best fit and talk about something called correlation. The important thing about today and tomorrow is 80% of the marks you get in Unit 1 are to do with what we're doing today and tomorrow. So, our smart recap to get us going for today. I'd like you to solve 1/3 plus 2/5, list 3 types of continuous data, and what is the value that the arrow is pointing at. First one then, 1/3 plus 2/5. Good. So you can't add thirds and fifths, so you need a common denominator, which is 15. Brilliant. So we're going to turn these 2 fractions into something over 15. So 3 goes into 15 5 times, so I have to multiply the numerator by 5. 5 over 15 is exactly the same fraction as 1/3. When we do the same for 2/5, 5 goes into 15 3 times. 3 times 2 is 6. So 6 over 15 is exactly the same fraction as 2 over 5. But we've written it in a different way. And by writing both of them in a different way, it means I can now add them. I'm not trying to add apples and oranges, I'm adding apples and apples. So I've got 5 15ths and I add 6 15ths, I end up with 11 15ths. Everyone okay? Can I simplify it? No. Why can't I simplify it? Brilliant. So we're now spotting prime numbers. 11 is a prime number. It doesn't go into 15. Therefore, I don't have to waste any brain power or time trying to do it. Unit 1 is a 1-hour exam with 54 marks. You can't spend 3 minutes trying to work out if you can simplify 11 over 15. Yeah? You need to spot the prime number. It doesn't go into the denominator. Continuous data. What is continuous data? Oh, brilliant. Okay, straight in there. So we've got time. Okay, so Jamie said time. So why is time continuous? When Ali came in 2 minutes late, I looked at my watch and it said it was 2 minutes past 3. Right? Is it really 2 minutes past 3?
It's 2 minutes.
2 minutes.
32.
32.87, and it goes on forever. The only reason it's 2 minutes late is because my watch is accurate to 2 minutes. So whatever we measure time with, a stopwatch I can get to about 1/10 of a second, atomic clock I can get to about 1/1000th of a second. But time is infinite, it goes on forever. We cut it off with what we measure. So the other things that Jamie was talking about were weight. So when I get on my scales in the morning and it says I'm a massive 82 kilos because I've porked out over Christmas, am I really 82 kilos? No, it's the scales telling me it's rounding it to 82. It's really 81.987 and it goes on forever. Okay? It's the machine that's doing the rounding. What's the other thing? Height, we call it length. Let's call it length. That's a better way of putting it. But height's same thing. It depends on what I'm measuring it with. If I measure it with a ruler, it's to the nearest millimetre because that's what rulers have on them. Okay? If I'm using a micrometer screw gauge, if you come across those, you can get to about 1/1000th of a centimetre. Yeah? So length goes on forever, depending on what we measure it with, depends on how accurate we are. And then finally, temperature. So when I was driving into work today, my car said 5 degrees on the dashboard. It wasn't 5 degrees. The machine in my car that measures the temperature, the thermometer, is just rounding it for me. But it's 5.1 and it goes on forever. Yeah? Good. The important thing about continuous data within Unit 1 is continuous data has its own special displays. And we're going to do those tomorrow. Okay? Frequency polygons and histograms are specifically for continuous data. And we'll cover those tomorrow. What value is that arrow pointing at?
27.5.
27.5. So when you're doing graphs, when you're reading graphs and information, which you'll be required to do in Unit 1, they will give you different scales along the bottom of the graph. You need to be able to read nasty scales like this. Our data cycle then. We don't produce data displays just because we've got nothing better to do with our time. We produce them because of this thing. And we did this before Christmas. Anybody remember what kicks off data? Why is data out there?
Collecting the data, and then
We don't just go straight ahead and collect data, we have something before it. Yeah, there's a problem or a question or a thesis that needs answering. You know, it's like, what is the average wage of teachers? I want to find out, I've got a problem and I want to find an answer to it, I've got a question. Anybody remember what the posh word for it was? What's the posh word for a problem in maths? In the exam paper, instead of giving you a nice easy word like what's the problem or what's the question, they'll use a posh English word, what's the hypothesis? John has a hypothesis. They're trying to stump you, they're trying to get you not to answer the question. So a hypothesis is a problem or a question that needs answering. So what's the next thing we do? My average wages of teachers, I go out. Good, I collect the data. So before Christmas we talked quite a lot about stage 1 and 2. Do you remember the 3 ways of collecting data?
It's like questionnaire.
Good, questionnaire was one of them.
Then looking.
Yeah, looking, we call that. When you're just watching the world go by, that's called observation. Yeah, you're standing there, you're just watching the real, and then the final way, I've got a coin and I want to prove it's fair, experiment, yeah, okay? So the 3 main ways to collect data, before Christmas we were talking about this, were observation, experiment, and questionnaire. Once we've collected our data, what do we do with it?
process.
Good. Process and present it. That's what today is all about. It's processing and presenting your data, more to do with the presenting. Okay? When we do statistical measures, mean, median, mode and range, they live in there as well. And then finally,
Discuss.
interpret it, discuss it. Does it answer my question? Remember, sometimes you might have to go around more than once. Okay? Happy with that? Good. So let's get down to what we're doing today and tomorrow. Today and tomorrow we're going to be looking at producing and interpreting those displays. Now, very rarely in the exams you have to create them from nothing. So to help this lesson go smoothly and quickly, I've produced this in-class worksheet. So these are the display types we're going to cover today and tomorrow. So we're going to start with a tally. Anybody tell me what a tally is? It's a chart. And what do we put onto this chart? So I've got this chart. What am I putting onto the chart?
Lines that represent.
Good. Lines that represent the data. Okay? We talked about the tally before Christmas. What was a really good thing about the tally? I'm at the canteen and I'm trying. Good. I'm trying to find out what people's favourite butter is. It's quicker. Why is it quicker?
Because whenever you get a line through the 4 lines, you just know it's a 5.
Good. So you can see straight away.
Yeah.
So, a tally might be really simple. Every single exam I've ever seen has had a tally in it. Okay? Whether you complete it from scratch like you will in a minute, or whether you're completing one that's partially filled in, you will get a tally. And tallies are really useful because they serve 2 purposes. They allow you to collect the data. So I could actually stand there outside the canteen filling in my tally. You know, I could say to you, what's your favourite butter? Oh, it's country butter. And I could go like that. So as I'm filling in my data on my tally in stage 2, I'm also getting a visual representation. Can you see which the favourite one is just by looking at it? Yeah. So at the same time, it's giving me a visual representation in stage 3 of which the most popular is or which the least popular is. So a tally might be very simple, but it's very useful because it does stage 2 and stage 3 at the same time. You can see visually, it's almost like a horizontal bar chart, which is the most popular as I'm asking people. What's the most important part of the tally? What does it represent? 5, yeah. It represents 5. Remember what it's called? You don't have to remember for the exam. It's called a 5-bar gate. When you do your tally in the exam, if you do not group things into 5s, when you're doing your exam, if you do not do the groups of 5, you will lose marks. So if you say, oh, that's my tally for almost like butter, you will lose a mark, because this is part of a tally, a very important part of a tally. They have to be in groups of 5 to allow you to add things up really quickly. Okay? So show me you know and understand the tally by doing the tally on the worksheet. So I've given you some raw data, and the raw data represents me spinning a wheel on a selector. And every time it lands on a number, I record the number. So 3, 2, 2. So I want you to complete the tally and give me the frequency. What's the frequency on a tally? What's that column at the end, frequency, all about? What did we say a frequency was before Christmas? Do you remember? Good. Again, it's a posh maths word for a total. They just want you to add your bars up. Yeah? Yeah? So what have we got then for our frequency? How many zeros?
7.
How many ones?
8.
How many twos?
8.
How many threes?
6.
And how many fours?
3.
3. So if this was a spinner and we'd just done an experiment and spun our spinner and collected our data and processed it, what would that tell you about your spinner?
How many times spin?
Yeah, but it tells you there's something wrong with it, because you would expect 4 to have as many as these. It should be more evenly spread. And we'll talk about that next week. Okay? But for now, that's a tally. Everyone happy with a tally? How to populate a tally? The questions you'll get is, what is the least popular number? It's 4. And they might ask you why. Because it might have a smaller sector, and there might be something wrong with the spinner. Okay? Good. What's a pictogram?
Pictures that represent.
Good. So it's kind of like a tally, but instead of using little dashes, we use pictures that represent whatever it is we're counting. On a pictogram, what is the most important part of a pictogram?
Picture.
Yeah, but something else. So that's me doing a survey of the colours of Smarties in a packet of Smarties. Everyone happy with what a Smartie is? Colourful sweets, okay? So I've got all my colours of my Smarties. There's my count, there's my frequency. What is the most important bit of information on there? Brilliant. Can everyone see that? So when you're talking about pictograms, you need to know what your picture represents. In this instance, one Smartie on here is 2, if that makes sense. Yeah? So 2, 4, 6, and half of 2 is another 1, 7. That's why I get 7. So can you see, in a pictogram, the picture represents a number of things. Okay? Not just one. With pictograms, you get questions on pictograms left, right, and centre. So here, the most important thing about a pictogram is the key. The second most important thing is that the picture represents the data you're trying to put across. So here we're talking about the number of cars people have in a particular street. And then they'll ask you questions about the pictogram. And they'll say something along the lines of, how many families do not own a car? Well, do not own a car is 1, 2, 3. But is it really 3? It's 30, because each car represents 10 families. So that's why the key is the most important thing. Okay? So you need to be aware of the key on a pictogram. So on your worksheets, you have a pictogram. So please do the pictogram question and answer the questions underneath. There are 4 questions at the bottom of the pictogram. So we're talking about DVDs. That's why you've got circles. And it says, how many music DVDs does he own? How many more film DVDs and comedy DVDs does Carl own? Carl owns 6 wildlife DVDs. Complete the pictogram. And then finally, give one advantage of using a circle to represent 4 DVDs. Let's answer the first question. How many music DVDs does he own? So music is this shape. So if a full one is 4, what are 3/4 of it? 3. Yeah? Because a half of it would be 2, and we're adding a quarter again, so that's 3. Yeah? So we've got 3 music DVDs. Second question, how many more film than comedy does he have? So how many film have we got? 22. And how many comedy? 12. So that's 4, 8, 12, 4, 8, 12, 16, 18, 22. Okay? Sorry, 20, 22. Carl owns 6 wildlife DVDs. Complete the pictogram. So in wildlife, what do I have to draw? Full circle and a half a circle. Good. We'll get that. Yeah. And then finally, give one advantage of using a circle to represent 4 DVDs. Good. It's easily divisible into 4. So when you think of a circle, It's really quite straightforward to cut it into 4 and show that on here. And people relate to that, especially when it represents 4, because a full circle is the 4, half is 2, a quarter is 1. Yeah? Excellent. Right, let's get on to slightly trickier stuff now. Bar charts. What do we have with a bar chart then? Got a title, you've got axis labels, revenue by year. You've got the categories for each of the bars. So you don't need a key on a simple bar chart because it tells you what they are. 2004, 5, 6, 7 and 8. You've got a scale that makes the most of the paper that you've been given. Okay? The bars are all the same width and there is a gap between each of the bars. The first bar does not touch the y-axis. Happy with that? That's what I've just said in words. I'm not going to show the words. So I'm going to leave this up when I get you to do the worksheet bar chart. So it needs a title, it needs axis labels, it needs a scale that uses the most of the paper. You don't want all the things scrunched down here. Your categories, Monday, Tuesday, Wednesday, Thursday, go under each of the bars. You have a gap next to the y-axis, and then you have an even gap between each of the bars, and the bars are all the same width. Are you happy with that? Good. On your worksheets, you have a bar chart to plot from scratch. And I'm going to talk about 2 other types of bar charts. Okay. Anybody heard of a dual bar chart? What does a dual bar chart do?
Is that when they're both together?
Good.
Amount.
Yes, we call that the data, sets of data. So it's really important that you understand this, and I'm going to show you the other display at the same time. Is that dual bar chart compares sets of data. So for example, we go to a school and we ask the students in year 7 what crisps they like, the flavour of crisps they like the best. Salt and vinegar, cheese and onion, ready salted and so on. So year 7, if we were just doing theirs, would be the blue one. Now in the exam you aren't going to spend time colouring in, you haven't got time to colour in. So when you do your dual bar chart, year 7 will be like that. Year 10 will be like that. You're not going to colour in, trust me, you won't have time. So we asked year 7 and it produces this information. We want to compare it against year 10. So we have another set of data, but for year 10. So to compare sets of data, you use a dual bar chart. So when we're looking at it, I can see really clearly, really quickly, that year 7 prefers salt and vinegar to year 10. I can see really quickly that year 10 prefer cheese and onion to year 7. Everything else for the bar chart is the same. It's got a title, it's got axis labels, it's got a scale that uses most of the paper, it's got the categories across the bottom. Let's just move this picture up a bit. It's got an axis label of flavours, okay? But the purpose of this chart is to compare 2 sets of data, right? It's an important thing to remember. Because there's another bar chart that you need to know about, and it's a component or composite bar chart. Anybody know what a component or composite bar chart looks like? Give you a clue. Looks like this. A component or composite bar chart puts one set of data on top of the other set of data so that you can compare categories. So this is still our year 7 and year 10, but this time year 7 are underneath, and then we add year 10. And the reason we do that is so that we can compare the categories, the flavours. So from this bar chart, it's not easy to see year 7 and year 10 side by side, is it? Because one's on top of the other. Okay? But it is really to see that salt and vinegar is the most popular. Ready salted is next, cheese and onion next. Oh, lo and behold, steak and onion and prawn cocktail are the same. If I try and do that with this diagram, can you see that steak and onion is the same as prawn cocktail? They're not. You see, it's impossible because you have to imagine that on that and this on this. So, the 2 bar charts you need to be aware of are a dual bar chart that compares the data side by side and a composite or component bar chart that compares the categories. Okay? And there is a real subtle difference with those 2 diagrams. This, it's easy to see which is the most popular or least popular category. This one, it is easy to see which set of data is the most popular. In other words, year 7 against year 10. Okay? So can you see the difference in the two? My experience of GCSE exams are that 9 out of 10 exam questions will be about dual bar charts. However, 1 in every 10 exams has a component bar chart. So you need to be aware of what it is and what it gives you. Okay? So if we look at the question you've been given, don't start it yet, about the table showing gas and electricity bills for the year, it's going to ask you to plot a dual bar chart and a component bar chart for this data. So what is my dual bar chart going to compare? What are my two categories going to be when I go to my dual bar chart here? What's one bar going to be? What's the other going to be?
Gas electricity.
Good. Because we've got two things, we need a key. Okay? So when you're doing your dual bar chart, you're comparing the two sets of data. Does that make sense? Yeah? You're comparing the gas with the electricity and you're putting them side by side. What do I do for my component bar chart here? What am I comparing?
The gas and electricity.
Good. Your first quarter, you're going this way. So you're adding the gas to the electric, if you catch my drift. So you're looking that way at component bar charts. You're looking at the data this way with a dual bar chart. Okay? So on your worksheet, I'll leave this up on the board for you. What I'd like you to do is on the first piece of graph paper is plot a dual bar chart for that information. The second diagram underneath it is plot the component bar chart for the same information. What's a pie chart? Good. And what does it look like?
Circle.
Circle. So our circle represented by a pie. So the trickiest thing you have to do with a pie chart in GCSE foundation level is to plot one from scratch. So when you've got a pie chart here and you've got, I don't know, sales for January, February, March and April, you have to label what each of the sectors mean. Sometimes when you plot them from scratch, you're just given a load of data. So rather than talk about words, I'm going to do it through an example. So everything you're putting into the pie has to go into 360. That's the secret of a pie chart. So here, I was in a shop before Christmas and we monitored 72 customers and what they bought when they came into the shop. 15 bought wine, 35 bought beer, 10 bought spirits, 12 bought champagne. Okay? So I know that when I add all these up together, it comes to 72. So to find out what one customer is worth as part of my pie, so I've got 72 people going into the pie, 72 into 360. Yeah, I've got 72 people going into 360 into the pie. So that works out as 5 degrees. They will give you nice round numbers. They won't say 2.17 degrees. It's horrible to plot. Okay. So each customer is worth 5 degrees. So you need to go back to your frequency table and plot 15 times 5 means that's 75 degrees. Yeah? So I've got 15 customers at 5 degrees per customer is 75 degrees. 35 customers at 5 degrees, 175 degrees. 10 customers at 5 degrees is 50, and 12 customers at 5 degrees is 60 degrees. Okay? Those must add up to 360, because that's all your data going into your pie. Okay? So what do you do next to plot your pie chart? So, to plot your first angle. So to plot the Y, anybody struggling with plotting angles? The centre of your protractor goes to the centre of your circle. Your reference line, your zero line, goes down the line of reference. So the one I'm going to get you to plot now is the last thing of the day for you to plot, are different sales of fruit juices, orange, apple, cranberry, blackcurrant and other. So you've got to fit all of those things into a circle. And the circle is 360 degrees. Okay. So see if you can remember what to do to get the perfect pie chart. So everybody's worked out that the one fruit juice is worth 10 degrees because you've got a total of 36. You're putting it into 360 degrees divided by 36, 10 degrees for every one. So you multiply each of these by 10. So you're plotting 180 degrees for an orange, 80 degrees for an apple, 30 for cranberry, 60 for blackcurrant, 10 for other. So if you're starting with orange, what is 180 degrees? We call it the straight angle for a reason, because a straight line gives you 180 degrees. So your oranges are the left-hand half of your circle, or right-hand half, whichever way you want to do it. And then from that point, you've got your reference line, you can plot your apples, cranberries, blackcurrants, and all the rest of it. Good. I'll let you just finish off. So if I carry on doing what I was doing, we draw a line down there, it's 180 degrees, and we call it orange. Everyone got a title? Needs a title. Call it something. I'll call mine, I don't know, fruit juices. Okay. Good. Everyone just about got it. So you should have 80 degrees for apple, so apple should be roughly over in that direction. 80 degrees apple. Then we've got cranberry 30 degrees, roughly that way. 30 degrees cranberry. Then you've got 60 degrees up there, and that's blackcurrant. And then other is 10 degrees. Everyone happy with that? Everyone happy with the displays that we've looked at today? Yeah? Good. Right. Please don't forget, pie charts in Unit 1 generally aren't about angles. They're about fractions and percentages. Let's crack on. Stem and leaf. Talk to me about stem and leaf then. James, you're just about to enlighten me.
It's let's see.
Good. So what you do is you have a vertical line that splits numbers up. And what does it split it into?
So it's 45 on the floor on the left and 5.
Good. Let's have a look at a stem and leaf diagram then. So a stem and leaf diagram takes your raw data. So I'm there and I'm asking people for the percentage they got in their GCSE exams, right? And I'm just pick 100%, 65, and I'm just writing them down. And I go away and I've now got to sort this information, okay? So the way it works is on the left-hand side of this vertical line, you put the tens. So you look at your lowest number and say, my lowest mark was 63 over there somewhere. So you put the 6 on the left-hand side, so you have to have 60, 70, 80, 90, and your highest mark was 100, so we need a 10 there as well for the hundreds, okay? Now, generally in the exam, they will ask you to sort it. So you can have unordered stem and leaf diagrams, and you can have ordered stem and leaf. So somebody here has collected all the 60s, and they've got another one, which is 68 somewhere. So this is unordered as I come across them. What they'll get you to do, 99 times out of 100 in the exam, is put an ordered stem and leaf together. So as you're doing it, you've actually got to say 63, 65, 67 and 68 like they've got on there. Okay. So stem and leaf means you separate the tens, which are the stem, from the units, which are the leaf. Okay, that's all there is to it. So on your worksheets, I've given you a very simple group of data, and I want you to create the stem and leaf from that. So let's have a look then. So the lowest number was in the 20s, and then we've got 30s, 40s, 50s, and I can see a 60 as well. So you should have 2, 3, 4, 5, 6 down the left hand side. Everyone happy with that? So the 20s I've got 21. What have I got for the 30s in order? 32, 35 and 38. The 40s I've got 2, 4, 4, 5, and that's it. 50s, 54, 60s. Good. Happy with that? So you should have that.
66 as well.
Oh, sorry, 66 as well. Good. Okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of information. What's the middle of 11? 6. Good. Yeah? So you can see what we're doing. If you divide 11 by 2, you end up with 5.5, and you round it up to 11. So, sorry, to 6. So 1, 2, 3, 4, 5, 6. That is my median, my middle number of all my data up here. The mode, which one's the most? 44. Don't forget the 4 there, so it's 44. So 44 is the median, 44 is the mode, and what's the range? What's my biggest number? And what's my lowest number? 21. So my range is 45. So 3 of my data statistics, I can do really quickly on that thing, and they're really keen on that, okay? Because stem and leaf on its own is quite a straightforward diagram, they like to show you how it can be used for median, mode and range as well. Good. Let's move on to line graphs. We all know line graphs, we've done them already, okay? We did them when we did coordinates in week 6. It basically plots one set of information against the other. This isn't a particularly good one because it needs a title. Okay. So, the things you have with a line graph, the title telling me what it's about, you have axis labels, you have scales that make the most of the paper and give you a decent way of reading the information. Okay? And generally it plots one thing against another. The thing about graphs in the exam is they rarely get you to do a graph from scratch. And graphs are more likely to be, if they're going to get you to plot one, in Unit 2. In Unit 1, they want to know that you can read graphs and graph information. So if I said to you, how fast was he going after 4 seconds? You go along to 4 and you read across that it's 18 meters per second. And so the sort of things they do is they might get you to plot a really simplistic graph. They can't give you anything massive because they haven't got the time. It's a very small exam. It's more likely to say, at what time of day was the temperature the highest? What time of day was the temperature the lowest? What's the difference between the highest temperature and the lowest temperature? Those kind of questions. So graphs tend to be more about interpreting graphs than it is about plotting them. Okay? Can you read the units? Can you interpret what the information is? Can you go along and read the time across the bottom? Okay? So the one that I've given you is actually something I'd like you to plot, and that is the months of the year against the cost in pounds of electricity bills for each of those months. We've already come across dual line graphs. All dual line graphs do are compare 2 sets of data on one display, much like we did with our component bar chart. Okay, we're looking at 2 lots of data, or our dual bar chart is a dual graph. So here I've got the rainfall for England and Wales in the year 2007. England's in red, Wales is in blue. Now 99% of the time they will just give you the dual line graph because you haven't got time to draw 2 line graphs. Yeah, it would take a huge amount of time. Okay, so much like the homework you've seen so far, remember we had the pen sales a couple of weeks ago? You know, which company would you buy 100 pens from? Dual line graphs are all about can you read it, understand it, interpret the questions and give good answers. So here, if I said to you, how much more rain does England get than Wales in June? They want to know, can you go to June? Can you read off where Wales is, and let's call it 200 millimetres? Can you go to June, go to England, read off 240 and get a difference of 40 millimetres for the difference in rainfall? That kind of thing. Okay. So dual line graphs, can you read them? Can you interpret the data? Okay. And this is the one that you had in your homework a few weeks ago, all about 2 companies selling pens. Company A is the dashed line, company B is the solid line, and the question went along the lines of, if you were going to buy 100 pens, who would you buy them off? Yeah? Or if you had £20, or what price, how many pens could you buy for £20 and who would you buy them off? £20, 200 pens, and because they cross, it doesn't matter which company you buy them off. Questions like that. In other words, can you interpret dual line graphs? Okay, good. I'm going to show you this display because it started to appear in more modern exams. I've never seen this until 2 years ago, and in the last 2 years it's been in 3 of the last 5 exams. Okay? Before that it had never been in an exam. And this is essentially a vertical bar line graph. So it's kind of a bar chart, but they use lines instead of drawing a thick bar. Can you imagine if it had bars, it would look like a bar chart, wouldn't it? Yeah? But they're drawing lines. But they're using them to show two lots of information. Okay, they're using it to show how many students have blue eyes, how many have hazel. Now, they've also used this to show frequency data against things like football matches, number of goals scored. So here, it's the same display, and this one came out of an exam, and it's on your worksheet as well, so I don't want to give you too much information on this. It's telling me that I scored 1 goal in 6 games. So how many goals did I score in total in those 6 games? Yeah, so the total number of goals is 6. I scored 1 goal 6 times. In this game, in 2 goals, how many games did I score 2 goals in? 3 games. So how many goals did I score in those 3 games? 6, because it's 3 times 2. So can you see how they can use it as a frequency table as well? Okay, it's a number of goals against a number of games. I scored that number of goals. So if you have a look at the one on your in-class worksheet, that vertical bar line graph, there are 2 questions on it. It's saying, what is the total number of goals scored in the 16 games? And then finally, in the next 4 games, the team did not score. Complete the diagram for the 20 games. Okay, let's look at the answers to these questions. What is the total number of goals scored in the game? What did we get for that? 37? 37, everyone get 37. Okay, it's 1 goal 6 times, which is 6 goals, 2 goals 3 times, which is 6 goals, 3 goals 4 times, which is 12, 4 goals twice, 8, 5 goals once, 5. 6 and 6 is 12, 24, 32, 37. Everyone happy with that? And then the second bit, in the next game the team did not score. Complete the diagram. So what do I have to draw to complete my diagram? Good. So from 0 up to 4. So that line completes my diagram from the information I've been given. Happy? Excellent. Right, let's move on to slightly more complicated stuff, okay? Frequency polygon. Anyone heard of a frequency polygon? Anyone tell me what it is? I'll be impressed. A frequency polygon is a fancy line graph for continuous data, okay? So when you come across continuous data like time and weight and length and temperature, you have to use a special display because the data is all joined up. And a frequency polygon is one of those displays. So if we talk about continuous data, and if we use it in a scenario, let's say I'm asking 50 people how late their trains were arriving at a particular station. So everybody happy with what this means?
Yeah.
T is time. So this group, because this is grouped data, is saying my train was 5 to 10 minutes late, but not exactly 10, it's less than 10. Here, if it was exactly 10, it would fall into this category, okay? So we're grouping our information, okay? So time is continuous data, so it has to run on continuously. So this can be 9 minutes and 59.9999 seconds late, and this one can be exactly 10 seconds late. So we've got no gaps in our data, it's continuous, okay? So when I asked my 50 people, 16 people said they were between 5 and 10 minutes late, 22 between 10 and 15, 11 people were between 15 and 20, and 1 person was between 20 and 25 minutes late. Okay? So that's the data I'm giving you. This is the continuous information we're tracking. This is the number of people who are that late. Okay? So a frequency polygon is a fancy term for a line graph. But this line graph is special. Because I've got grouped data, in other words, I haven't got one number to plot against another. Yes, I can plot 16. I need to know what I'm going to plot for my group data. Anybody tell me what I plot for my grouped data?
It's in between.
Good. Everyone hear that? It's the midpoint. So because I can't plot my time 5 to 10 on a line graph, I take the middle point between 5 and 10, which is 7.5. I take my midpoint between 10 and 15, which is 12.5. I take my midpoint between 15 and 20, which is 17.5, and my midpoint between 20 and 25, which is 22.5. Okay? So now, because I've got one value against another, I can plot a line graph. So I put my time across the bottom, 5 minutes, 10, 15, 20, 25, and I put my number of passengers that were late for each of those times on my y-axis, my frequency. So if I go to my first bit of data, 16 people, so I go up to 16, against 7.5 minutes. So I put my cross there, 16 against 7.5. 22 is against 12.5. 11 is against 17.5, and 22.5 plots against 1. So can you see how to plot a frequency polygon? You take the midpoint of your grouped data and you plot it against your frequency. And it's called a frequency polygon, but it's a fancy expression for a line graph, okay, for continuous data. So it doesn't have to be time, it could be temperature, it could be length, it could be weight in that column, okay? So when you come across a question that says, use an appropriate display for continuous data, one of those two displays is a frequency polygon. Everyone happy with that? With what a frequency polygon is? Good. Okay, so on your in-class worksheet, it gives you this table of information and it asks you to plot a frequency polygon. Histogram. Anybody like to hazard a guess what a histogram is? Anyone heard of a histogram? Heard of a histogram? Yeah. Bar chart. Right. You know how I gave you a hard time about leaving gaps between the bars on a bar chart? Because if you don't leave the gaps on the bars on a bar chart, it's a histogram. So a histogram is the second way of showing continuous data. Okay? So if in an exam they say, draw a display to show this continuous data for time or weight or length or whatever, they're after either a frequency polygon or a histogram. Now the frequency polygon is a posh word for a line graph. A histogram is a posh word for a bar chart, but a bar chart with no gaps to show something is continuous. That's why I always stress you have to leave a gap when you're doing the normal bar charts, because if you don't leave the gap, it's not a bar chart, it's a histogram. Okay? So it's very, very similar to a bar chart. So this is the same information we had before about our trains running late, yeah? Between 5 and 10 minutes there were 16 people, between 10 and 15 minutes late there were 22, and so on. Okay? But this time, because we're not plotting one point against another like a line graph, we can actually show this 5 to 10 minutes, this data being continuous. And the way you do that is on your bar chart, between 5 and 10 minutes, you join it to the 10 and 15 minutes. So the bars are right next to each other, yeah? Before, when we were drawing bar charts, it was discrete categories. It was flavours of crisps, it was quarters of the year, it was gas or electricity or whatever. But now we're trying to show continuous data. So to show the continuous data, we've got to put our bars together to show that time is continuous. So for this example here, where we've got 5 to 10 minutes, 10 to 15, 5 to 10 minutes, we draw a bar that goes up to our frequency of 16. Yeah, nice and straightforward. So a histogram is a posh way of saying a bar chart to show continuous data. In other words, the bars are together. Okay. So on your worksheet, the exact same data that you use for your frequency polygon, if you flip your worksheet over, you should have the same information to draw a histogram with that data. Excellent. So, nothing clever about frequency polygons, nothing clever about histograms. But the thing to remember is they are the two displays for continuous data. Now, sometimes they won't give you a diagram on a histogram or a frequency polygon. They have these wordy questions saying, if you were going to plot continuous data, which of the following would you use? And it will say bar chart, line graph, histogram, something, frequency polygon. And they expect you to circle the frequency polygon and the histogram. And that appears quite often, yeah, that sort of question. Good. And that's a final reminder. So if you get a question on continuous data, they are after either a frequency polygon or a histogram. Okay? That's why we keep going on about this continuous data and which are the four, so that you recognise them in the exam. Scatter graph. What's a scatter graph? Somebody describe a scatter graph. something to do with the graph, so I've got axes. What does it do? What does it show? What does it look like? I'll give you an example just to show you what I'm talking about. Let's say I want to know, so I'm talking about my data cycle, and I want to know, is there a relationship with somebody who's good at maths is also good at physics? Okay, let's say I want to do that. And I go around and I ask, I don't know, 25 students what scores they got for their maths exams and their physics exams. So student number 1, I say, what score did you get? And he said, oh, I got about 30 in my maths and I got 18 in my physics. So I put a little cross there. I asked the next student, what did you get in your maths, what did you get in your physics? And he says, oh, I got about 22 in my maths and I got 38 in my physics. And you put that little cross there. And they should be crosses, not dots. Okay? So what a scatter graph shows is the relationship between two sets of data. And what's that relationship called? Correlation. Okay? So this word we're going to look at in a minute, correlation, okay, is a posh way of saying, is there a relationship between these things? James went on to say, when you've got your information like this, you can draw what they call a line of best fit. So I've plotted all my data for all my maths students and my physics students. Okay, I've asked my 25 students, what's your maths score, what's your physics score, and plotted them. The next thing we do is we say, right, is there a relationship? Can I draw a line through the middle of all that data that would represent that data? Okay? So I don't draw it up here, I don't try and go through any points, I don't try and go through 0, 0. I just put a line, a straight line on there, the best way I can to show that it's in the middle of all that information, roughly there. Yeah? Can you see what I've done there? So I'm not trying to draw it to go through 0, I'm not trying to draw it through any lines, I just put that line as close to as many of those dots as I can. You'd put it in a different place. That's Pete's estimate. Your estimate, would all be different. And when they ask you questions about why would this be different for somebody, it's because it's my estimate and not yours. What I see with my eye as the best line of best fit is different to everybody else's. Okay? So that's one thing to remember about scatter graphs. Now once I've done that, we need to talk about this thing called correlation. If all of the dots are right on top of my line, that's what we call strong correlation. If the dots are spread out quite a bit like they are here, that could be weak correlation. If the dots are all over the place and I can't actually draw a line, no correlation. Okay? Now when it goes this way, can you remember what you call it? That's called positive correlation. So here I've got weak positive correlation. If the line went down the way, it would be called negative correlation. But you need to say whether it's strong or weak. Okay? So it plots two sets of information. You will be asked to plot a line of best fit. You will be asked to discuss what sort of correlation it is. Strong or weak, positive or negative. There's one final thing I want you to do, is once you've drawn your line of best fit, okay, they will say, okay, Joe Bloggs is a student, he's just joined the school, and he gets 40 in his maths test. What do you expect him to get in his physics test? Well, because I've drawn my line of best fit, I can go to somebody who's going to get 40, and I can read off, he's going to get around 39 marks in his physics test, according to my line of best fit. The next question they will say is, why would it be different for somebody else, or why is that an estimate? And it's an estimate because the line of best fit is my estimate. Your estimate will be somewhere else, and then when you plotted 40 against your line, it would be somewhere else. It would be 42 or 36 or something, yeah? And you'll see that in a minute when you get to do one. When I ask you a question on, right, what is the value for this? You'll all come out with different answers because all your lines of best fit will be different. Okay? Sorry?
There's no correct answer.
They'll give you a range of correct answers as long as you're not like 20 out. If you said, right, 40 and it's 80, there's something very, very wrong with your line of best fit. You see what I'm saying? So your line might be down a little bit or up a little bit from mine. So they give you a little bit of flex. They'll say 40 plus or minus 5. If you're beyond that, your line of best fit is obviously wrong. Okay? One more thing about scatter graphs. Good. There's something called an outlier. So if I have a guy who scores like 10 in his maths exam, but 90% in his physics exam, okay, bit of a strange result, but compared to the rest of my data, it's miles away, isn't it? It's out on a limb. We call it an outlier, and you're meant to circle an outlier to show I'm not even going to take this into consideration when I'm doing my line of best fit. Because if you try to include that in your line of best fit, it might drag it this way a little bit. So the point of outliers is one set of data that doesn't relate to the rest of it, and it's out on a limb. What you're meant to do when you draw your scatter graph is circle your outlier and ignore it when you come to draw your line of best fit. Are you happy with that? Yeah? Here's another scatter graph. So it's similar to what I'm going to get you to do. Title, axis labels. Anybody seen this before? This zigzag. What that means is I know there's no data between 0 and 20, and rather than go 20, 20, 15, 10, 5, 0 and have a lot of wasted paper, you can draw these zigzags to save space and say it goes from 0, it jumps from 0 to 20 because I know there's no data below that point. I know there's no data to the left of that point. Does that make sense? Yeah? So that little zigzag represents there's no data below there. So if my data started at 100, why would I have 0, 5, 10, 15, 20, 25, 30, 35, 40? I can just go straight to 100, okay? So here, I've plotted the temperature on a particular day against the number of ice creams that I sell. So when I'm talking about my data cycle, my question is, do I sell more ice creams on hotter days? Yeah? I went round and in a week I recorded the temperature on that day and the number of ice creams that I sold on that day. So on the Sunday it was 20 degrees and I sold 35 ice creams. On the Tuesday it was 26 degrees and I sold 39 ice creams. So to show the correlation between the temperature and the number of ice creams I sell, I plot the temperature against the number of ice creams. Okay? So on the Sunday it was 20 degrees and I sold 35 ice creams. So 20 degrees plotted against 35. And when I plot all that information, my scatter graph looks something like that. Now what they will do next is say, draw a line of best fit. So my line of best fit, very, very roughly, kind of goes something like that. Maybe a bit that way, I don't know. That's just me roughly drawing it, okay? So can you see why I've drawn the line where I have? To try and get to as close to as many of these as I can. I don't have to go through any of them. I don't have to go through 0. What you can then do is say, on the next week, when I'm getting up in the morning, the weather forecast tells me the temperature is going to be, I don't know, 25 degrees. How many ice creams do I estimate I'm going to sell? So you go to 25 degrees, you go to your line of best fit, you go across and you expect to sell around 43 ice creams. And that's why we do scatter graphs and lines of best fit, because we can use the data we've collected to predict what we're going to sell on particular days. Yeah? Correlation. So correlation is either positive or negative. Positive or negative. The line of best fit is drawing a line that goes to as close to as many of the dots as you can. So generally it goes smack through the middle. Smack through the middle. Sometimes it's not that easy to do. Okay? An outlier would be a point all out on its own. Okay? So I think I've given you a study that we've did, and what we've said is there a relationship between the age of the students and their arm span? So if you look at your in-class worksheets, you should have this data on your in-class worksheet. What I'd like you to do is plot the scatter graph points for this information, circle any outliers, draw a line of best fit, and then we'll talk about it for a couple of minutes. Good. Okay, so as far as objectives are concerned, we've now covered all of the display types that you need to cover within Unit 1 exam. As we went along, we talked about those graphs and what they give you and how to read and interpret them. But finally, for scatter graphs, we've talked about correlation, which is showing you the relationship, and the fact that they're strong or weak, positive or negative. Okay? We talked about lines of best fit. The line of best fit is your estimate, which is different to mine.